So question number 8, 6 marks. This is f of x, where k is a positive real number. Consider a particular case when k equals 6. So when k equals 6, f of x is going to equal x on top of 2 square root of x plus 6. Show that this derivative equals this. So think about integration by recognition for this question down here, because I'm told what the derivative is. Okay, so I've got to show this is this. So it's a product rule. U equals x, u dash equals 1, v equals x plus 6 to the half, v dash will be a half, x plus 6 to the negative a half, therefore dy dx of x, the square root of x plus 6, will equal this times this, x on 2, x plus 6 to the negative a half, plus this times this, which is x plus 6 to the positive a half, which is x on top of 2 square root of x plus 6, plus the square root of x plus 6, which is exactly what we have there. Done. Okay, hence or otherwise evaluate this definite integral. So this is still as part of A. These are indented, so k still equals 6. So I'm looking for the integral 0 to 6 of x on top of 2 square root of x plus 6 dx. And I know from up here that x square root of x plus 6 will equal, if I integrate and integrate, the integral of the square root of x plus 6 dx plus the integral of x on top of 2 root x plus 6, which means that x square root of x plus 6 minus this integral, x plus 6 to the half dx, should equal the integral of x on top of 2 square root of x plus 6 dx. So I can then write this to equal, so that's what this is, x on top 2 root x, so it's going to be the square brackets of x square root of x plus 6 minus, and the integral of that will be x plus 6 to the 3 on 2 divided by 3, and the 2 will go up there from 0 to 6. So that's going to equal 6 root 6 plus 6 is 12, minus 2/3, 12 to the 3 on 2, minus nothing, because when you put in a 0 there, that goes to 0, plus 2/3, 6 to the 3 on 2. Okay, 12 to the 3 on 2 is root 12 cubed, which is 12 root 12. So I've got 6 root 12 minus 2/3 of 12 root 12 minus nothing, plus 2/3 of 6 to the 3 on 2 is going to equal the square root of 6 cubed, which is 6 root 6. I've got 6 root 12 minus 3 goes into 12 4 times, 8 root 12 plus 3 goes into 2, 4 root 6. Which is going to equal root 12 is the same as the square root of 4 times 3, which is 2 root 3. So that's 12 root 3 minus 16 root 3 plus 4 root 6. It's going to be negative 4 root 3 plus 4 root 6. I'm going to say 4 root 6 minus 4 root 3. It could be in any other form, but that's what I'm going to leave it as. Okay, so over the page, the last question on the exam. So I've got to do the same thing, but in terms of all k's. So what do I know from the previous page? So I want the integral from 0 to k of x on top of 2 square root of x plus k dx. And I know that that's going to equal, from the work that we did on the previous page, x square root of x plus k not 6 minus 2/3 x plus k not 6 to the 3 on 2, which will equal k root k plus k is 2k minus 2/3 k plus k is 2k to the 3 on 2 minus nothing plus 2/3 to the k to the 3 on 2. So k times root 2 root k minus 2/3 to the 2 to the 3 on 2 is root 2 cubed, which is 2 root 2. 2 root 2 k root k plus 2/3 k root k. Now I can see a k root k, a k root k, and a k root k, which is good because the form I need to leave it in is k root k. So I've got k root k outside of root 2 minus 4/3 root 2 plus 2/3 equals k root k. I'm going to put all of this over 3. That becomes 3 root 2. This is already, so minus 4 root 2. And this is already over 3, so that's over 2. So I've got on 3 root 2, so that's minus root 2 plus 2, k root k. So if I rearrange that as 2 minus root 2 all over 3, k root k, that's the form that I want. Done.